Okay, so.
Okay, sure. So let me copy and let me add images. Okay, cool. Here it says if m is a proper divisor, g of m is less than g of n, and from positive integers to positive integers, right? It says m and n are relatively prime. We have this and greater than 1, right?
Right.
So, for example, we can use some small examples, right? The m and n cannot be equal, right?
Right.
Okay, so if we want to use g of 1, we know g of 1 is less than all other g's, right? That n is greater than 1, right?
Yeah.
Okay. Here it says m and n are relatively prime. So the first case that we can check is m and n are equal to what?
2, 3.
Exactly. M, for example, 2 and 3. And the idea, if we switch m and n, both sides are symmetric with respect to m and n.
Yeah.
Okay, g of 6 is what? Is g of...
G of 2, G of 3. Oh, the actual value?
It's g of 2 times g of 3, right?
Right.
Plus 3 times g of 3, right?
4.
4g of 2 plus 5. Okay. So, for example, if we know g of 2 and 3, we can find 2016, right?
Right.
So, we can consider something. If we know g of what numbers, then we can find g of all numbers.
G of the prime factor.
Primes to the power of alpha, right? It is similar to the problem of SUMaC or many problems that we consider prime factorization, and from that aspect we try to find use small examples, right? Okay, like a problem of AMC 12. Do you remember it was sigma something f of n over d it was 1? Do you remember that problem? Something like this, d times in AMC 12. Do you remember that problem? It was problem of AMC 12 2023. And in that problem also we should use same idea. Okay, so now we can understand that we have to find only f of primes to the power of alpha, right?
Right.
Okay, so let's focus, for example, on 2 to the alpha. Okay? And now, 2016, prime factorization of 2016 is what? It's multiple of 8, right?
Oh,
Last
2 raised to 5, 3 raised to
2, 8 times 4 times 6, 3. It's 2 to the 5 times 3 squared times 7. You said this?
Yes.
Okay, so we should find f of, for example, 2 to the 5, f of 3 squared, and f of 7. Then we can find this, right? Or g of this, I mean, right? Okay, so if you want to find g of, for example, 2 to the alpha or p to the alpha, let's calculate p to the alpha. How can we find, for example, g of p? And it says least possible value, right?
Right.
So, can we find g of, for example, p to the alpha in terms of something else?
You can find it in terms of alpha, right?
In terms of what?
Oh, no, sorry. You can't find it in terms of g of something else because there's no relatively prime.
Okay, so if you want to use, for example, p of alpha, we should replace m and n with what?
Oh, you can.
Okay, so let's see. If we consider, for example, you said we can't calculate p to the alpha.
You can't calculate using the second part, like the b, the g of mn equals g of m, g of n.
So if we want to use this, can we calculate g of p to the alpha?
No.
We cannot calculate, right?
Yeah.
So if you want to calculate g of the idea here, we should calculate p to the alpha for the p1, p2, p3. to the alpha. So first let's consider when we have two primes. Okay?
Right.
P1 alpha 1, P2 alpha 2. Then it will be what? G of P1 alpha 1. Can you tell me G of, for example, P1 alpha 1 is at least what?
At least alpha 1 plus 1.
At least alpha 1, because we know that G of 1 is less than G of P1.
Isn't it at least alpha 1 plus 1?
Yes, because the reason is this G of 1, G of P1 alpha 1, right? G of 1 is at least 1, so P1 at least 2. So this one is at least alpha 1 plus 1, right?
Right.
Okay, so we can write G of P1 alpha 1, P2 alpha 2, plus what? P1 alpha 1 plus 1 times G of P2 alpha 2, right? Plus P2 alpha 2 plus 1 times G of P1 alpha 1, right?
Right.
Plus P2 alpha 2 plus P1 alpha 1. Agreed?
Mm-hmm.
So we can say it is at least what?
At least alpha 1 plus 1, alpha 2 plus 1,
like this.
P alpha 1 times alpha 2 plus 1.
G of P2 alpha 2, we can write alpha 2 plus 1, right?
Yeah.
And next one, P2 alpha 2 plus 1, alpha 1 plus 1, plus P2 alpha 2 plus P1 alpha 1, right?
Right.
So can we write it in a better form?
I think could write it in terms of isn't it like P1 alpha 1 times alpha 2 plus 2 or something
If you write it, for example, alpha 1 alpha 2 plus 1.
It's alpha 1 plus 1 and times alpha.
This one, right?
Oh, okay, okay. Oh, okay.
But here we have some problems when we write like this. We can create this, we can create this, we can create this. We can create also these parts, right? But something or we should subtract something.
P1 alpha 1, P2 alpha 2.
Only this.
There's only plus 1 plus 2. Minus 1?
Yes. Now the agree we can say this one is at least this.
Okay.
Okay, so now if we consider last part this one for P1 alpha 1, P2 alpha 2, P3 alpha 3, right?
Alright.
Okay, if we apply this, your solution was this or different?
It was this, but I didn't factor.
Okay. And without factoring also you can reach, but let's calculate this one here. P1 alpha 1. So if you want to factor the agree, you can say it is G of M plus N plus M plus 1, right?
Right.
G of N plus N plus 1, right?
Right. Minus MN.
Minus Mn minus 1, right? Oh, one good thing. Do you agree G of Mn? I think we solved some problems in PMO similar to this. Do you agree we can say this one plus M plus 1? With this way it will be so much easier. Do you agree all these things have same form?
Oh, okay.
I remember we solved some problems similar to this before. You remember?
Oh.
This one is f of m. This one is what?
F of n, and then G of f, f of mn.
Exactly. So now with this way, do you agree it's so much easier to calculate?
Yeah.
F of m. And now want to solve with this new idea first on your own or want me to tell you?
I can try to solve.
Okay, sure. Try to solve with f of mn, okay?
Oh,
I got 3053.
Again, same answer, right?
yeah.
This approach was easier.
Yeah.
Okay, so let's check it. F of 2 to the 5, f of 2016 is f of this. So f of this is equal to what?
F of is equal to f of 32, f of 9, f of 7.
F of 7.
F of
Yes, then what?
and then f of 32 is g of 32 plus 32 plus 1.
Yes.
Which is wait, no. Yeah. Sorry, yeah. And then g of 32 is 6. So
At least 6 plus 33, 39.
And then f of 9 is g of 9 plus 1, which is at least 3 plus 10, or 13. And then f of 7, g of 7 plus 7 plus 1, which is at least 2 plus 8, which is 10.
Okay.
And then that's 5070.
5070. This one is what?
G of 2016 plus 2016 plus 1. So you subtract 2017 and get that it's at least 3053.
It's 3053, you said?
Yeah.
Yes, exactly. We can say this, and if someone says, okay, your example is what? Our example is what?
When g of 1 is 1 and then g of p
P to the alpha is what?
alpha plus 1.
As for this one, then we can say this, right?
Right.
And we can conclude, in this case, f of p1 alpha 1 to pk alpha k is what? We know it is equal to f of p1 alpha 1, right? Because it is for the case that GCD of m and n is 1, right? So f of p2 alpha 2, 2, f of pk alpha k. We can say it is equal to what?
That's equal to alpha. It will be alpha 1 plus 1 plus p1 alpha 1 plus 1.
Let's times these things, right?
Uh-huh.
And if you consider pk alpha k plus 1. So if, for example, m and n are relatively prime and we define f equals this, then it will be correct, right? Because we have different primes in each of them, right? And when this condition is satisfied, then we can say G also will be satisfied by the definition of G, right?
Right.
Okay, this is our example, and we proved. Okay, good job. And we have also another definition, but this example for the case that it's minimum, right?
Right.
Okay, any question about this?
No, I think.
Okay, sure. Any question?
No, I think.
Okay, so have a good day.
Have a good day. Thank you.
Thanks. Bye.